all these symbols? Less than, greater than or equal to, and less than or equal to. Remember, less than looks like an L, a slanted L, right? No, you don't remember it as Pac-Man and stuff, because otherwise you won't know what the actual symbol means, right? So anyways, less than is like a slanted L, just like your left hand is slanted. That's how you can remember which one's less than and greater than. Because you're going to have to be able to translate things from words to inequalities. And if you don't know what they mean, then it's not going to work too good. So anyways, for example, A is greater than 3. That would be A is greater than 3. A is less than or equal to 7. Sorry, B is less than or equal to 7. That would be B is less than or equal to 7. So a double inequality, you have not necessarily seen this before, but a double inequality has two inequality signs in the same statement. So if G is greater than or equal to 5, but less than 11, you break it down. I always like saying G is between 5 and 11, not including 11. That's how I prefer to say it, rather than G is greater than or equal to 5 and less than 11 at the same time. So we're going to have to be writing our domain and range this way. So this is where we're going with this. So let's practice here. I'm going to give you a second to do example 1. You need to translate the words into symbols. Actually, do example 1. Yeah, just do example 1, and then we'll go over it. Okay, you should have a less than sign like that. For A, greater than or equal to, you have the extra line underneath that. E is greater than -2, looks like that. Yes? F is less than or equal to 4, has the extra equal sign underneath the less than sign there. So did everybody get that right? Okay, good. So now we're going to practice the double inequalities. So G is greater than 2 and less than 10. So I don't know if I agree with how they're explaining how to do it. Like, so most people could probably just write it at this point. But anyways, if you don't understand it, I'll show you this way because this breaks it down a little further. So how would you write G is greater than 2? Well, that would be like that. You can also write, and this is where the Pac-Man or whatever comes in, when you have the 2 and the greater than is eating the G, when you rewrite it on the other side, do you see it's like that? Okay. So then how do you write G is less than 10? Well, that's G is less than 10 like this. Now we put it together. We take this and put it with that, so then our final answer would be 2 is less than G is less than 10, like that. Again, I like saying it as G is between 2 and 10, not including them, right? Because that's essentially what it means. G is between 2 and 10. So just another way to look at this is, if you had a number line here, and here is, I don't know, I'm just going to put a couple numbers. I'll just put, actually I'll put 2 here, and it's not going to be by scale at any means or whatever. So if it is 2 is greater than 10, how would you graph that? It would be a circle not filled in going this way, right? Do you remember the circle not filled in and filled in? Yes? And then less than 10 would be a circle not filled in going this way. And so when you combine them together, do you see that together they're the overlap of the 2? Do you see that? So this graph, essentially open circle going this way to open circle, is the same thing as this representation right here. Okay? Because you're going to see this on the graph, and you're going to have to find the domain and range and stuff like that. So up until this point, our domain has just been specific points, right? Now we're going to have like everything in between. So it gets a little bit more complicated. So H is greater than -5 and less than or equal to 6. So h is greater than -5, so that would be like that, right? -5. Then we write it this way. This is what I'm saying. I don't think anybody would actually do it this way, but again, if you're having trouble, you can do it this way. And then h is less than or equal to 6, so h is less than or equal to 6, and we put that together, okay? So then what is this as a combined inequality? -5 is less than h is less than or equal to 6. Okay, so something you got to know about this is you always write it with the less than signs. You never write, if I ever see this, you get it wrong. If you had it like this, that would be wrong, okay? It always has to be written as least to greatest, okay? So you would never, ever have greater than signs, thus, because it has to be written least to greatest. So maybe put a little sign there, must be written least to greatest. Okay? So when you state your domain and range, it's always, if you have this range of numbers, it always has to be least to greatest. All right, so now we're going to come up with a new test for a function. Remember, how do I figure out if something's a function or not? Yes, for every input, there's only one output. So there is an actual test so that you can look at it graphically and tell in like 2 seconds. It's called the vertical line test. And the way the vertical line test works is you place a ruler, or you can use your pencil or whatever, vertically on the graph, and you slide it across the graph. And if one edge of the ruler always intersects the graph at no more than 1 point, then the graph is a function. So for instance, on this one right here, do you see, no matter where I have my pencil, it's only intersecting 1 point at a time. So that means it passes the vertical line test, which means it is a function. So this is a function. Passes the vertical line test. Okay, so I'm going to abbreviate vertical line test as VLT. So going back to the definition of a function, when x is -2, y is -1. When x is -1, y is 0. Do you see, for every one, there's only one y or output, right? So now let's scan this way. Do you see right here? It fails the test. It went through 2 points. Yes? So this is not a function. Fails the vertical line test. Okay, so does everybody understand how to use the vertical line test on a graph to see if it's a function or not? Pretty easy, right? Yeah. So decide whether it's a function or not. So I'll give you 2 seconds to do A and B. If you want, you can just put checkmark function, X not function. Okay. So Jace, is A a function or not? Yep, it is. Function. Emily, is B a function? Nope. Not a function. Okay, and where did it fail? Right there, right? Yes? Well, it's a good thing you... Okay, let's see if these are a function now. I'll give you a second. Okay, is this one? Yes, is this one? No, it fails it right there. Yeah. Okay, so when the points are joined, which means it's a continuous graph, We use inequality to write the domain. There's no way I could actually write every single point. And maybe you don't realize this, but a line is basically all these little points connected so close together, they're forming a solid line. So there's no way I could actually come up with every single x value. Do you know what I'm saying? For the domain and every single y value. So that's why we were going over how to write the domain and, the inequalities. So can anybody just tell me in words what the domain would be for A? What would the domain be for A? Remember, domain is your x values. So what would, I'm sorry? So I heard -2, 0, and 2. So that's incorrect. I'm sorry? No, the x's is scanning this way. We're not going this way. That's your y's, right? Okay, so I will repeat. A line is so many points close together, it forms a solid line. So for you to say the domain is only -2, 0, and 2, you are only hitting that point, and that point. So let's, yes, it's going from -2 to 2. And how do we write that using an inequality? So our domain, yeah, so we have to write the in-between one that we were practicing. So what is domain, our variable? Okay, so x, so leave a space here, okay? So x is between -2 and 2. Okay, does it equal -2 and 2? Can it equal -2 and 2? Yes, because there's an actual solid point on there. So you put a little equal sign underneath it. Okay? Now the correct way to actually do the domain is you actually have to tell me what x represents. And that's where you're supposed to say x is an element of the reals. So you go x, and then you do this fancy E that looks like a curved E. Like it's not, it's an actual, like, it looks like a sideways U with a slash through it. And then it's got a fancy R, which has got a, it's like an R with an extra vertical line there. It's a special kind of font or whatever. And then there. So what that means is x is, do you know what real numbers are? Basically, real numbers is any number you can ever think of, right? When a number isn't real, what is it? No, not fake. Imaginary, yes. So when you're in the real number system, that involves fractions, decimals, integers, natural numbers, whole numbers, any kind of those regular numbers that you can think of that your calculator will use, right? Your calculator is essentially a real number function machine, okay? So basically what I'm saying here is x can be anything in the real number system between -2 and 2, okay? So now we're going to say our range. So we're going to begin it with y is an element of the reals. So y can be anything, but it has to be between what and what? Y has to be between what and what? 0 and 6. Do you know where you're looking? 0 and 6. And can it equal 0 and 6? Yes. So what whoops, I put the line under the wrong one there. Okay, so what I tell people to look at, when you're scanning your domain, scan your pencil from left to right and kind of go, when does it start hitting it? And then go, oh, beep, 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 and then nothing again. So you know it's from -2 to 2. And then scan your pencil vertically, So start from the bottom, because remember we always go from least to greatest. When do you actually start hitting y values? Oh, right there. Beep, beep. What's that? 0. Go, beep, 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 all the way up to 6, and then after 6 is not anymore. Do you see how you should be scanning it to see where it is? Okay. Okay, just so you know, when the line goes like that, that's an arrow. Okay? So if it doesn't have an endpoint, it means it's got an arrow. So I'm going to give you a second to think about B, and you're supposed to find the domain and range. Okay? I'll give you a second. So, first off, x is an element of the reals, comma. Now, is x between two things? No. So what do we write here? Yeah, so when we have one-sided inequalities, we always have x listed first. So x is, no, greater than or equal to -2. Yeah, so if you wrote it back, so get in the habit is if it's a one-sided inequality, you write the variable first. When it's a two-sided, you have to make sure it's least to greatest. Okay? Oh, I see what you're saying. No, it's only the two-sided. When you have a starting and an ending, they have to be least to greatest. But when you state it as a one-sided inequality, the variable, I didn't tell you that, so I'm sorry. Okay, let's try the range. So y is an element of the reals. Okay, let's see if we can get this one. What are we starting with our range? Huh? Y is greater than or equal to -1. Yes, -1. It starts at -1 is the lowest y value. Do you see that? And then goes up forever. Yes. Okay, so who's going to tell me my domain here? So x is an element of reals. Lily, what's very good. So x is between -2 and 3 and including it, or -2 is less than or equal to x is less than or equal to 3. Close it up. Okay, so my y, who would like to tell me my y here? Liam. Yeah, very good. Okay, this one might be hard. I don't know. Domain, range. Okay, x is an element of the reals. Oh, Gavin? It is. Very good. X is less than or equal to 1. Very good. Okay, and then my range. Liam again? Very good. Y is greater than or equal to -2. All right. Okay, so let's look at the next example here. It's saying here's a graph of a function y equals f of x. By the way, again, it has arrows here, and you need to write arrows heads on your graph. For some reason, the program that this has puts dots if it's an endpoint. Otherwise, you're supposed to assume it's arrowheads. But for all purposes, if you're like drawing a line on a graph, you have to have arrowheads or you're going to be losing marks. So, anyways. Before I do this, well, we can find the range, and I guess we can do A and B first. This is pretty easy. Just, you need to interchange domain with X and range with Y. So essentially when they say find the range value when the domain is 2, they're essentially saying find the Y when X is 2, right? So what is it? Yeah, 5. And find the domain when the range is -3. What would you say there? I'm sorry? Yeah, -2. Okay, so this is where I was going to add a question to it. Who can tell me my domain and range? Who can tell me my domain and range? Okay, I heard X is an element of the reals. And then we don't say anything. So, can you tell me in words what the domain is here? Brooke? It is every number. Yeah, anything, right? It's going on forever to the left, and it's going on forever to the right. So, guess what your domain is? X is an element of reals. Done. So when it's everything, all you write is X is an element of reals. Okay? So, range. Who can tell me? Yeah, now it's easy. Y is an element of the reals. Yeah. So if your Y is everything, then you write Y is an element of reals. Done. I heard something about negative and what did you say? Infinity? Heard somebody say infinity. Who said that? Somebody said that. The person is not paying attention, I think. Oh, you were? You said it? Okay, what did you say? Infinity, yeah. Well, essentially, when we say it can be anything, it's an infinite number of domains, right? But when you get into grade 11, this is called set notation for stating your domain and range. And when you get into grade 11, you learn what's called interval notation. And so interval notation basically states the starting and the ending. So does anybody know if X is an element of reals, what would the starting and the ending be? Yes, negative infinity to positive infinity. Very good. And really, negative infinity isn't a number, but we're saying as a concept, it's negative infinity to positive infinity. It's not a number. Okay, let's keep going. We have one more here. Again, this is an arrow, right? So what's the range when the domain is -2? What's the range when the domain is -2? 6. Find the domain when the range is -4. 8. Okay. So give me a second here.